Hello to everyone. I'm Andrea Manghini from GMAX Support and Training Team, and today I will present you the latest webinar dedicated to the Data Integration Bootcamp. So how we can manage all the data on our X-PAD Office Fusion software, so our Office solution. Just to talk a bit about the topics of this webinar, we will have a small introduction just to talk about this data project. Then we will see together how we can integrate this data, all this data already acquired, already processed and during the latest webinars, with a stereo drawing from the X-Photo tools, how we can manage the data with the surface and volume calculation using the X-Top model, also the Design 3D application. Then we will see together some other output that we can create and share from X-PAD Office Fusion. Just to remind you, just to quickly explain you about this project, the Data Integration Bootcamp is a webinar series dedicated to the X-PAD Office Fusion software, and through several applications, we will already show you how we can manage the topographic data, how we can also integrate this data with the laser scanning data, X-Photo data, so aerial and terrestrial photogrammetry data, plus also some other application that we already seen during these webinars. Just to talk about the hardware that we already used, we use the GeoMax GNSS receiver, so the Zenith 40 and Zenith 35 Pro tag. The Zoom 90 is a robotic TPS from GeoMax, Leica BLK260 laser scanning, DJI drone, and also a reflex camera, plus also another example were performed using a simple iPhone. And then, of course, from Fusion, we have different possibility also to share the data and create some output, like for example, drawing format, PDF 3D formats that we can also share with the customers, so share with also other users. Create reports for topographic data for the surface and volume calculation, 3D formats. We will see also during this webinar, point clouds, and all sorts of photos. All these dataset and this guide are already available on our X-PAD 365 platform. So you can also subscribe to the platform for free in order to receive the updates from GeoMax, or you can also have access to the multiple services by subscribing other applications, other tools. And of course, this guide and this data and output data are already registered using 3 different folders according to the different modules that we have on our software, X-PAD Office Fusion. Okay, so during this webinar, we will see how we already integrate the data using the drawing from the photos, surface and volume calculation. Then we will have an overview about how we can also export the 3D project and maybe print it using a small 3D printer. Okay, back to the project. This is a project, and as you can see there, we can overlap all the information on the X-PAD Office Fusion software. What does it mean? It means that all the information, all the data set that we already imported on the software or created in the software are already registered in the project manager. And we can easily deactivate or activate the data that we want to visualize or not. For example, the orthophoto created by drone, point clouds created by the X-Photo model, so photogrammetry model. TPS and GNSS data, so the blue one are points measured with the TPS, the green one are points measured with the GNSS. We can easily activate or deactivate, or using the filters, for example, for the surveys, and deactivate only the measurements and the GNSS base. So Zoom extension, we will focus only in the current project area. So back here, service, and as you can see there, we have some other outputs already visible there. For example, point cloud measured registered with a BLK 360. And here we have also the other 3-point clouds. For example, iPhone, we used an iPhone to register the data for the small gray bar outside the area. We used also the reflex camera to integrate part of the facade. So this is only the point clouds. Here some other. Okay, let me switch off also the drawing. So the mesh created. This is part of the point clouds created with the reflex camera. So only for integrate this project. And the entire point cloud registered with the DJI Mavic drone in the survey court, in the golf course. So what we can do more on this project? For example, we can activate the equalization to check also the data measured. We can also integrate the drone and the mesh created by drone. So now we can directly integrate this data and create our drawing on the point clouds, directly on the surface, on the mesh, or directly using the tools from the imaging menu, stereo drawing. How we can use this functionality? This functionality allows us to use the images acquired during the survey, so during the photogrammetry survey, and for example, we can draw this part of the parking area which is not acquired by, for example, by the GNSS. For example, those are the points measured with the GNSS, and here in this parking area we have no points, so we can use directly the images acquired there. Okay, so drawing, polyline, and as you can see there, we are redirected to the surveying area. We can directly select our points here and have automatically the points also on the graphic area. So in the right side, we have the stereo drawings tools. And here we have the graphic view. We can directly select with the right click of the mouse, close. Now, selecting the polyline, we can directly change by using another images that, for example, can be okay from the other side of the parking area. So once completed this process, we can directly select apply. Yes, some point of occurrence. And now this drawing is integrated in the same project area. We can do another drawing in the other part of the project. Oh, sorry. Undo last point, undo last point. Here we are. So we are creating also close. And as you can see there, we can switch off the data in the background. So, and we can directly adjust also this polyline. Again, using the smart drawing tools. Apply. And we create also the other part of the parking. Okay. So basically this functionality is based on the stereo plotter functionality and allows to use multiple images to change the vertices of the drawing. Okay, so we can also switch off part of the data. This is the flag session, so we can hide this part because we don't need it at the moment. And now we can concentrate on the surfaces. So for example, this is the surfaces created by the DSM of the X photo model, which includes all the data. Let me switch off also the Canon, so the point cloud. And this includes all the area measured with the surveying by the drone application. We can, in that case, since this area is already measured with a GNSS receiver, here we have also the result, we can also create a small surface which include only the topographic points, just to compare the area measured with the drone and the area measured with the GNSS receiver. How we can do? We can directly move to the surface menu, new empty surface. We can enter a name of the new surface. And then we can also use the tools to create, for example, the breakline or to create an external perimeter. In that case, we can create the surface for the entire GNSS surveying area. So this will be our external perimeter. We have the snap also on the points. Okay, I can also not include these points because we cannot use it for the comparison. Right click, close it. Now we can decide directly to build a surface. So moving to the surface menu, build surface, and we will use only the shared Google field topographic data. So sorry, this is the autosave of the project. And as you can see there, since we already created our external boundary, we can use boundary line. We have also some other option that we can include, for example, to split the breakline to near point with a zero elevation. So also to remove the pixel. So imagine that, for example, this could be really useful in case you want to create a surface on the point clouds data. In some cases, you can have some sparse point, which not allows you to create the best surfaces according to the correct data project. And we can also decide to create a color based on a fixed color by elevation or color on the points in case you created point cloud, in case you create surfaces on point cloud data. Close. So in that case, we already created a surface. We can activate the surface created by the drone. I will change also the properties of the second surface in order to let you understand the difference. And now we can concentrate in part of the surface on which we will not have this peak created by the drone DSM. How we can do? Surface. I just want to create a surface difference, so to compare the two surfaces. And I want to use also the calculation zone in order to limitate this calculation. I can use the calculation zone from a previous polyline already created, or I can directly create the polyline here on my dataset. And for example, I can just select, okay, name. Okay, name one. Now I can select the points directly on the surface. Stop command. And this can be our area comparison. So calculate, here we have some tools to calculate a volume by a fixed elevation, by picking up a point on the topography point, or using the snap on a surface, on a drawing, on all the other elements already inside our project. Between two surfaces, reference plane, stock and pile pit, or fill analysis. In that case, we want to compare two different surfaces, which could be our DSM drone surfaces and our GNSS surface, plus also a calculation zone that we already created. Calculation method by triangles, by regular grid, and here we can directly select, for example, triangles. Cut and swell factor, in case also you want to use some other parameters for the weight of the terrain, and calculate. So in that case, we can easily understand the difference between the two different surfaces measured with the drone and measured with the GNSS receiver. Okay, here we are. As you can see, we are a small difference between the two. I can also create my report here. Summary report or report with the images. And of course, I have also the possibility to customize my report, including the label of the company, including the label of the project, or adding also some information about the surveyor which performed the project or which can perform the survey on field. Okay, now we are summarizing all the data. Plus also the report, which include also the volume calculation. And then I can store my report okay. No, I don't want to open it. I can select no and close it. Okay. And now, for example, we can move to the export folder. Oh, sorry, I should be in another folder. Oh, I didn't save the project. Let me do it again. Okay, calculate. It will take a few seconds to recalculate it. In the meanwhile, if you have any question, you can also use the tool, the GoToWebinars tool, and directly ask me some questions, chat with me. I will reply to the question also at the end of the webinar or during the presentation. Okay. Save surface distance difference. Surface distance differences here. Okay. And create also the elevation surface distance. Okay, now we are saving this calculation in our volume calculation, so we can directly access to this information in the second time from calculated volume. Here we are, and create also from here the report, so we have access to the same information also in the second time. Okay, let's switch off also this part of the data. I will also delete my area, calculation area. And now, for example, I can use another tools, which is called the Design 3D ribbon, to create, for example, another bunker in the golf course. How I can do it? I can select, for example, drone. I can switch off all the project here. And then I would just want to create a new bunker in this area. And, for example, calculate the excavation area in order to create this new bunker. So, drawing. First of all, I just want to check the elevation in this precise point, so it's 8 meters. So we can directly draw in a different elevation without using the snap on the drawing, and then use another tools from Design 3D in order to overlap the surface, the polyline on the surfaces. Okay, polyline. For example, since it was 8 meters, I can select 9, and now I can create the bunker here. 2D in order to be exactly orthogonal to this part. Right click to close it. We have also some other tools that we can use for the drawing. For example, after selecting the first point, right click on the mouse, we can also select to contain the polyline using an arch, or directly after selecting the arch, selecting the line, or using the extension. This could be really useful in case you need to drawing on a facade and you need to find the intersection between two different planes. Okay, let's switch off also the snap. So now this drawing is created in a different elevation. We can move to Design 3D, lay to surface, select the corresponding surface. In that case, is a DSM created by the drone. And now it's already projected on the surface. I can also create something different. For example, new, I create a new drawing layout. And now since this drawing is in a different layout, I can directly select drawing, bunker, and move to the corresponding layer. So now it's in the correct layer. Okay, so surface. Okay, here we are with the drone. Perfect. Now, how we can do? Now we just want to, we already overlap this drawing on the surface. We can move and use the offset to project in a different elevation this polygon, and then we will use the side slope to create the excavation. So now we will use the editing functionality dedicated to the drawing, but also we can also apply to the different option, to the different data set that we have here. Offset. I will create my offset using the value, not for horizontal, only for the elevation. So minus, for example, 10 centimeter. Let's switch off the drawing in order to understand. And now this is created in a 10 centimeter difference. Now we can also do something different. We can delete this polygon which is overlapped to the surface. We can use Design 3D in order to automatically triangulate the polygon. Let me before create a new surface. We can call it bunker. So this is the current one. Just to not create the same another surface in the same previous surface. Triangulate polygon. Surface is bunker. Select, enter, and automatically we create a surface. Now, for example, we can activate the previous DSM. We can rotate it. And as you can see, this is the new bunker is not overlapped to the surface, but we can create directly the excavation using, for example, an offset. This is our polyline. And now we can enter the values. For example, horizontal offset. In that case, we can enter, for example, 5 centimeter. And as elevation, we can enter 10 centimeters. So in that case, we can overlap to the map. And then the software asks us the direction, inside or outside the polyline. So in that case, we need it outside. And as you can see, we already created excavation with a 50% slope according to the dataset that we are using. And now what we can do? Now, for example, if we switch off this DSM, we have only the surfaces for the bunker. And again, we can create a new volume calculation using, for example, surface. This is our current surface. We can add a new zone. Okay, enter. We can limitate the calculation on the specific area. And stop the command. Okay, now calculate between two surfaces, DSM surface and bunker. Yes, I need to use my zone, and I want to use all the triangles. Now, basically, I'm calculating my excavation here, which I can also share with other surveyors in order, for example, to stake it out and create our real bunker based on a project. I can also do something more. For example, we will convert the polyline. Okay, save it. And this is our excavation. We'll create also the surface for excavation. Okay, now for example, we have our drawing here. Okay, let's close it. Okay, bunker. As you can see there, this is a simple polygon from survey menu, tools, transform drawing to survey. We can also create a new survey. Stake out, tools, transform drawing to survey. Add new point, for example, ST1, and select the object. Okay, let's switch off the drawing here. Okay, this is not a drawing. Oh. Sorry, I deleted the drawing before. Okay, we can easily create this in 3D. Surface perimeter, bunker. Drawing is bunker. Okay. Now we have the perimeter. We can move back to the survey. Tools. Transform drawing to survey. Again, ST1. Select the object. Yes. Enter. Apply. So now we already created all the points. Maybe we'll use only part of it in order to limitate our excavation zone. And we can directly send this information to a surveyor in field, and he can directly use this point, stake out, and create the perimeter area for the excavation. We have some vertices, so it will take some seconds to create it. Then after this part, we will see how we can export also the mesh created and create an OBJ file. We can directly use and import. Okay, maybe too many points. We can directly import, close. We can directly import in a 3D printer. So from file, we can of course create a report for all the measurement for the surfaces and volume. So we have also here the possibility to create the volume calculation report, but then we can also export and create the 3D format. For example, here we can use this tool. Okay, this is the, yes, okay, export. Okay, we can assign the name and we can decide what we can export, the tools that we can export in order to print this area. And for example, we have the drawing. So in that case, is the mesh. We have the mesh created with the X photo tools. We have the surfaces, so we can also export in an OBJ file the surface is created. For example, we want to share with a customer also a 3D model, a real 3D model about the surveying area of the golf course plus the bunker. Or we can directly export the iPhone 3D mesh drawing about the grill. And in that case, we can create a 3D model. The OBJ file is a file that can be directly imported in a 3D printer software. So without any kind of, without perform any kind of cleaning, without perform any kind of new calculation, we can directly import it. So pack, export folder. This folder is the same here. So okay. So the final web, I will use my 3D printer software and create directly the model in the proprietary format that we can print. Okay, and then we can directly drag here all the information. And this is exactly the same procedure according to also to other 3D printer software. So this is another tool so that we can share in real time, and then we can also use to demonstrate our area, our project. So as you can see there, we can have the grill. This is the external grid. This is the wooden meter plus the target used to create also to scale, to let me show you, to scale also the project. I will directly show you the result here. So grill bar plus also target used. So 1 meter and 60 centimeter difference in order to create 3 points and scale the project. Also, even if you are in field without any kind of topographic instrument, that can be TPS or GNSS, we can directly create our topographic project using 3 points, our iPhone or our smartphone, and create our photogrammetry project. Create the 3D model and maybe print it. So here I can also decide the model of the printer, resin type, so we can also create our estimation for the price of the printing. Slice parameter. So in order to, we can also change this parameter in order to create a better 3D model. And the result is exactly there. So let me open it. So this is the video of the 3D printer. So I've just set up everything. And now in 1 hour and 10 minutes, I created a small project of the grill bar. And I can also use the same option, and you can also the same workflow in order to create also other 3D mesh, other surface they can also print. And the result is there. As you can see, we have also the targets and the Wooten meter. We can, of course, optimize the layers in order also to create a better layers and maybe visualize also the small lines, the small layers of the court, of the wall court. So basically, in less than 1 hour, we create more or less than 1 hour. So then you can also clean it. We create a model. You can also create a separate model for the other part of the survey. So for example, for the facade, or for example, for the graphic court, and then directly print it. So this is also one of the other options that we have to export this data. By using our software, is it also possible to export the data and, for example, to publish the point cloud. What does it mean, publish a point cloud? It means that we can, for example, create a point cloud of the surface, or create a point cloud of the iPhone project. By selecting point cloud, we can export the true color, the quoted, the distance, inclination, so to recolorize also this data set. And then we can directly assign, for example, to a different folder or to drive, and also create a publisher for the self-extractor. It means that if you want to share your point clouds with a user or with a customer who is not so confident with X-PAD Fusion, or who is not so confident with a point cloud software, you can export this dataset. He will receive, you can share with him, he will receive an XF file, so a file that he can directly download in his software and use to visualize the point clouds, measure, rotate, scale. So your project will be directly shared with someone else who is not so aware about using point clouds data. So now we are publishing this project, and then I will show you how we can also import and integrate all these data sets. So point clouds from drone, point cloud from photogrammetry, TPS and GNSS data, surface and volume created in the software with the BM file directly in the X-PAD Fusion software. So in that case, we can use this software as a complete database, activate or deactivate only the information that we want to visualize or not. And here we have also the option to visualize the point clouds. I can also show you the folder. So what we have here is an Excel file. Sorry, here we are. Excel file that you can directly open on your laptop and visualize the point clouds. Okay, this is the self-extractor. In the meanwhile, again, if you have any question, please write us on chat or use our email, academy@geomax-positioning.com. Okay, let me open it, for example, directly here. This is another point cloud created in the same project. So this is the self-extractor. It's called LSA Cloud Point Viewer. If you already have the Xscan model, this option is already included and allows you to export and share this point cloud also as a viewer format. Okay, it takes a while to extract everything. And here we are. This is our point cloud viewer, free of use. Okay, is uploading the point clouds. This is the other self extractor now is going fine. Okay. Okay, let's wait for this one. This is the result of the point clouds. Okay, something's going wrong here. That's nice. Okay, sorry for these things. Okay, we can come back. We can also select, for example, another option. Okay, so bunker, we can switch off everything and we can import the BIM file here. Okay, this is the point clouds. Drawing. Now, home, BI model. I can import the BL model of the facade. I create a simple model using the Revit software just to show you that we can also include this part of the data. Okay, now it's refreshing also the visualization. Okay, this is a small project performed really in 6-7 minutes, only to create a 3D model and show you that we can also import and overlap this information. So edit, move. I can move to the other points. Oh, sorry. You see, let me check one of the points that we have here. I will move and transfer here, and then I will align. Okay, it's quite there's too many points. Okay, for example, I can select TS28. Perfect. Move. Okay, zoom extension again, and now we will. I can directly activate the surveys, and we can visualize, and we can of course align the BIM file. Okay, this is not the correct position. Should be here. So what we can do, we can directly select the BIM file, select align. Okay. I can also select the points from the point clouds. And another points, no, I'm fine. Scale the project, no. Here we have also the the project. We will check if I did something wrong. Okay, so this is the facade. I'm quite sure I did something wrong, but I can directly modify the position. Okay, align. This is the Smart Magnifier, an option that allows us also to work with the point clouds data. Okay, here we are. We overlapped also the information about the project. I can switch off the point clouds. For example, I can switch on the Canon. As you can see there, we overlapped also the information. And for example, we can directly create some points or stick out directly here. Stop. Switch off point cloud, switch off the EFC. We can switch off also the camera. We can create, for example, the drawing directly on the facade. So let me activate all the BLK 360 point clouds. I will use also the tools view, vertical, in order to hide part of the project. Okay, it takes time because now the Smart Magnifier is activated. So let me switch off the Smart Magnifier. Okay, save. So we will hide this part of the data only partially. And then, for example, we can directly draw on the point clouds. I can also create drawing my projection plane. Measuring 2 points on the facade. Here we are, and now we can directly drawing into the, okay, new drawing. Okay, here we are. Draw, polyline. And now we can activate the Smart Magnifier. So now we can directly select the points. The software will open the Smart Magnifier, so this kind of zoom lens. And we can directly select the corresponding point. So after created this window, we can also copy and paste in the same project. And the result will be, of course, in 2D. Right click, close it. So now we select it, we can select it, edit, copy. We can select the vertex. And we can directly copy the windows. So as you can see, it's also easy to manage the point cloud data and create our dataset, our elaboration. And all the elaboration or the view or the different visualization that we can create on Fusion are registered in Project Manager. Copy. Here we are. So for example, we created the small windows. We can switch off the projection plane. And now we can use the output object and create automatically the report for these windows. Enter reports. And this is another tools that we have to create a report. An image that want to easily create the report for the drawing that you already performed. You can use these tools. Of course, you can use segment, polylines, or all other object that you already drawing already measured with also with the survey. Plus with the images of the localization. Another option is to create, close, directly the node on the point cloud, on the project. So point cloud, we can switch off everything. Now home, area, 3D area, and store annotation. And automatically in that case, if we create also the ortho photos, this include also the calculation, so the area, the note about the area of the windows. Sorry, okay, here we are. Close. So as you can see, in a few seconds we create a part of the facade, but includes all the information that we have. Okay, let's switch on also the smart magnifier. We can select one of the angle of the facade. You can easily understand the angle. Okay. I will select randomly the points, and then I will use the smart magnifier. Okay, this is the angle. And this is the other angle of the facade. Close. Now we can close the measurement area. We can create an orthophotos, and also orthophoto will include this calculation. So close. Perfect. Now view, clipbox, vertical clipbox. Okay, we can also select a different height. We can also change and modify the elevation using the gizmo. And let's check what we can include in this project. Okay, so now the orthophotos will include only the dataset in this cube. So imaging, generate, orthophotos, clipbox, yes. We can select the clipbox and we can select the facade, the face of the clipbox. Okay, then in order to create the best result, we need to decrease this value. For example, using 2 centimeters, the pixel resolution will be not so high, not so accurate, but we can create first in this pixel resolution, and then we can, for example, change to 1 centimeter or to a few millimeter in order to increase also the quality of the point clouds, or the quality, sorry, of the ortho photos. That in that case will include the point clouds, the nodes, and also the drawing. So automatically we have the report of the facade, of the windows, and all the meter square of the facade. Okay, again, if you have any question, please write us on chat, write me on chat, or using our email, academy@geomax-positioning.com. Okay, let's switch off all the point clouds. And as I told you before, all this data set, all this guide are already in our X-PAD 365 platform. So feel free to use it and feel free to contact us in case you need something. So, okay, clipping box, and this is our calculation. And of course, what we can do, export DWG.xf file. We can select the extension here, version of the AutoCAD, export with the same AutoCAD color palette, and now we can export all the information in the same project. For example, the survey, for example, the mesh. It's up to you, the information that you want to share with your customers or with other users. Here we know, I think the EFC file no, because it's not supported by AutoCAD. And then in a single file, we can export all this data set. Okay, let's come back to the presentation. So also in our website, you can find our video tutorials for X-PAD Fusion. So feel free also to use it, and again to contact us in case you need something else. Thanks to you, all of you, for the participation for all these 4 webinars of this webinar series. Again, I will be at disposal in case you need something. Also, you need some dataset, and please write to our academy@geomax-positioning.com. So thanks again for the participation to this webinar series. I hope that you enjoyed it. I hope that you can now use better our X-PAD Fusion software. So thanks again, and see you in the next webinar.